So hello, I'm Dave Saylor. I'm a professor in the School of Geographical Sciences and Urban Planning at Arizona State University, and I direct the Urban Climate Research Center. Yeah, so I first came to Portland and Portland State University in around 2003. And at the time, the city was very interested in facilitating the more widespread deployment of green roofs across the city. They were particularly interested in it from a stormwater management perspective, but they wanted to gather additional information on how green roofs have co-benefits in the environment. And so one of the co-benefits they were interested in was a topic that I'd worked in, which is how green roofs could potentially impact the urban heat island. So could you cool the city during the summer by putting green roofs around the city? They were also interested in the question of whether green roofs can provide energy benefits for the buildings that they're on top of, whether it's air conditioning in the summer or heating in the winter. And so I initially did my modeling work for the larger urban heat island question. And so we used a mesoscale atmospheric model where we incorporated a simplified version of vegetated green roofs on buildings in that model. And we prepared that work for a workshop that the city of Portland was participating in. And our initial findings were actually that green roofs had only a modest impact on the urban microclimate unless they were irrigated. So if they're simply dry, established sedum roofs with very little irrigation, they really didn't have much impact on the urban heat island. But if they were irrigated, then the story was much different and they could actually provide a significant benefit. And another aspect of that study that we found was that while you may have heard in sort of in the media and the sort of non-scientific literature, there's a lot of talk about how green roofs can benefit the urban heat island. There's a little nuance there, which is that during the daytime, if they're irrigated, a green roof surface can be as cool as a white roof, a conventional highly reflective roof, and therefore can keep the city cooler during the day. But at nighttime, the green roof actually has more thermal mass, so it stores heat during the day, and it actually remains warmer at night than a conventional membrane roof. So that was one of the sets of findings that we had from that study. And related to that, I became very interested in the impacts on buildings because I had done some work on building energy, but the consultant that the city of Portland was working with to try to estimate the energy benefits of green roofs was using a very simplified Excel spreadsheet type model to try to estimate the effects of green roofs. And it was overly simplistic, and it gave me some concern that it may not be accurate. So that's when I started to work on developing an integrated green roof model where I took a very standard biosphere atmosphere model that's used in atmospheric modeling to model vegetation on the Earth, and I put that on top of a building in a very well-known and well-trusted building energy simulation software called Energy Plus from the U.S. Department of Energy. And so I integrated those two components and was able to develop this new model that allowed us to estimate the impact of green roof on energy consumption for the building. And what we found was that it matters, of course, how well insulated the building is, how efficient the building is, how much air exchange you have in terms of natural ventilation or air infiltration into the building. It also matters what kind of building you have. So if you have a residential building versus a commercial building, office buildings are typically conditioned during the daytime hours during the workday, and then they're allowed to float a little bit at night, whereas a residential building needs to maintain thermal comfort throughout the night as well. And so our model actually allowed users then to model any kind of vegetated green roof they want on an actual building. One of the problems with that model was that it really required some expertise in building energy simulation. So you couldn't give it to your average architect or average planner and have them do anything useful with it. What they really needed was a simpler model. And so what we ended up doing was we decided, let's create a very simplified user interface that is essentially a lookup tool, where we ran 8,000 simulations for buildings across the US in different climates. We looked at old construction, new construction, we looked at office buildings, and we looked at apartment buildings. And we used that suite of 8,000 simulations then to inform this simple interpolation lookup tool that we call the Green Roof Energy Calculator. And even today, that tool is still available at my website at Arizona State through my center. In fact, I just had an email this morning from a user of the tool who said, "Hey, the tool is down." So I was able to find out that there was just a small glitch in our IT. So that's now fixed. But basically, so we were able to create this tool then that can be used by anyone from policymakers to students to planners to try to assess, how much of a benefit might you have in terms of energy use if you put a green roof on a building, and how does the design of that green roof affect that performance.